Hello everyone. So in this video we are going to see Leetcode daily problem, and today is 12th December 2023. So the problem name is maximum product of two elements in an array. So you have been given an array and you have to return the maximum value of the product of two elements, something around that, because you have to do minus 1 as well from that element. You have to decrement those elements by 1 and then you have to multiply them to give the maximum product. So for this array 3, 4, 5, 2, answer would be 12. Why? Because if you choose these two indexes and you pick element 5 and 4, then 5 minus 1 is 4, 4 minus 1 is 3, 3 into 4 is equal to 12. That is the maximum product that you can create using two elements in this array. Now, there are a couple of ways to do this question. Because the constraints are pretty less, and this is about 500, we can do n square solution as well. So in n square approach, what we do, we just do basically iterate over each combination of I and j, and then update our maximum based on that. Max is equal to maximum of current max, comma this current value which is giving it. So ai minus 1 into a of j minus 1, and we can return mx. I need to define the for. So now this should pass, and this gives correct answer. One approach is this: we can try to submit it. It will submit, I think, and will get successfully accepted. But what we can do, that we can use this observation that to get maximum product, uh, maximum product is coming from the elements that are maximum in itself. Like only those two elements. Let's say you have to pick the maximum two element from the array and multiply them. It's something like that. So how do we identify the maximum two element in the array? You can do just basic sorting, right? Sort a dot begin to a dot end. What it will do, it will just sort it up, and the maximum element is your end, and the element present at, let's say, the last two indexes. Yeah, that's what I'm saying, right? So that we can have like int mx is equal to, or you can just directly return something like a of n minus 1 into a of n minus 2. But yeah, you need to decrement it by 1. That's given in question. This will also pass. So this is order of n log n approach. You just did a sorting and then yeah, you are good to go. Similarly, this maximum element finding can also be done by priority queue. That is some kind of a standard thing, that we insert all the elements from the priority queue and we want two maximum elements, so that we can do in n log k approach. I think that is also fine using some kind of priority queues, right? Let me tell you how. But first of all, I think let's submit this as well. Now let me tell you the third approach, which is using priority queue. So create a priority queue. Now the approach which I'm going to tell you is, we don't insert all the elements into priority queue. Rather, we just insert two of the elements, and based on that, we just have two elements at a priority queue at every moment. And when a new element comes, we check that if it's big enough to get inserted into priority queue, then you will pop some element which is smaller than it and insert that. So what we are doing, we are kind of having a min heap, okay, minimum priority queue. So that is not that how you create that. You create it like this. I think like this, priority queue. And now what you need to do, You say q dot push a0, and I will also do q dot push a1. Okay, now I will start my for loop from 2, and if q dot top is less than ai, we do something q dot pop and q dot push ai. This all we need to do, and we return. So first max 1 is equal to q dot. It's actually max 2, and q dot top, then q dot pop, then max 1 is equal to now q dot top, and we can return mx1 multiplied by mx2. This can be third approach, which is not n log n but n log 2, something like that. The good thing about this, we have solutions as well over here. I don't think we can do this with order of n solution. What is error in this? You have to do mx1 minus 1, mx2 minus 2, minus 1, sorry. Submit this up. Yeah. What I was saying is that I don't think we can do somehow order of n, because okay, nums I is up to 1e3. We can have a something like that. What we do in count sort, that we can make an array of size this, like the range, and we can put elements like how many times it's occurring and what are the elements that are there, and then we can identify the index which is non-zero. But that would be, yeah, that would be order of it would be obviously if n is up to 500, so 500 log 2 is the maximum time complexity here, right? Worst case time complexity that you have got 500 elements. In that case, over here it would be 10 is per 3 time complexity, which is up to 1000. But both are obviously very, yeah, easily doable, but still we prefer that. Okay, so let's see the solution. So the first is brute force approach, then there is a sorting kind of approach, track second biggest element approach, or biggest and second biggest. So yeah, I think this is how they have done in order of n. Yeah, we can do it in order of n as well, right? Yeah, by like we don't want just order of something like you know many element. We just want two elements. What is maximum and what is second maximum. Okay, then what we can do is that for I0, like one of the approach which I see is very good for this is the maximum, right? Int mx. Now what you need to do is that for I0n, you'll only see if it is okay, and mid. Let me create maximum id as well. So when you found some element which is greater than the current maximum, you update the current maximum, plus you say that maximum index is equal to this index id. Now if this I is not equal to mid, now you have to find maximum among those elements which are not maximum. So this will give you second maximum. Now what you just need to do is that return mx into mx. Let's name it as mx2, mx minus 1 into mx2 minus 1, and you have to keep a variable for mx2 as well. And now we are good to go, I think. This is order of n, this is also order of n, so yeah, order of n only. N is not defined. How many approaches I've done for this question? I think 4 approaches. But yeah, all of them are very good and you can do it. It's like, yeah, one over other. Like, how do we reduce time complexity for 24 millisecond to 3 millisecond? So that is what is basically need to be done with easy questions. You have to try them with all the angles. Okay, guys, thank you. Bye.